Hi everyone, welcome back to my channel. What I'm trying to do on this video is do some repair on my 187 scale bus here that I converted some time ago to a Fuller system vehicle in order to drive itself on my layout. I decided to replace the battery that it's using to a bigger capacity one to enable it to run on the layout for a much longer time without needing to be recharged. I also thought that the motor it currently has is too small for it, that's why I'm going to swap it with the bigger one as well. In the process of doing it, however, I somehow managed to damage the wiring inside the vehicle pretty bad. I was trying to remove more plastic material from the bottom of the vehicle using my cutting tool here to fit the bigger battery and motor inside. But the wires got entangled with the tool, messing up most of the wiring connection inside. You can see how these wires got cut off, and now I have to do some rewiring to fix it. I was using this smaller motor here for this bus, and it felt like it was a little too small for it, and I thought I should swap it with a bigger one here. I was also using this smaller 100 milliampere hour capacity battery, and I'm going to swap it with this 380 milliampere hour one to provide the bus longer running time in between recharge. I had a request from a recent video featuring this fire truck here running around my layout if I can make a video on how I built it. I'm thinking this could be an opportunity to show how I made it. It's going to be a little different since it's a different type of vehicle, but the procedures are basically the same. Let me show you the parts and materials that I use when I'm doing a conversion. These are the motors I use, the bigger one for larger vehicles, and the small one for cars and smaller vans. This one here is the front wheel mechanism that enables the front wheels to turn. A small magnet is glued to this metal part here, which follows the wires that are installed under the road pavements in the layout. This is a switch to turn the power on and off. This is a charging port which makes it possible to charge the battery inside the vehicle using battery charger. This part here is a reed switch which enables the vehicle to stop at certain areas in the layout when a magnet is placed close to it. This is the board I use to connect all the components to run the vehicle. It comes with this instruction sheet here which shows how these parts are supposed to be connected to the board to make it work properly. It also offers an option to install infrared transmitter and receiver, which avoids the vehicle choosing the same system from bumping into each other while running on the road. The small board here I used for emergency lighting for emergency vehicles, like what I have in this fire truck. And of course, these are the rechargeable lithium polymer batteries to power the vehicle. I got all these parts from eBay and some from Amazon as well. For the headlights, taillights, and emergency lighting, I use these tiny SMD LED bulbs. I use a soldering iron to connect the wires to the bulbs, but you can also buy the bulbs pre-wired if you don't want to do it on your own. I use this 34 gauge magnet wire to wire the bulbs, and sometimes this 32 gauge one as well. You can see the holes that I drilled on the plastic body of the vehicle here, where the wires will pass through to install the headlights and put the transistors used for distance control. Before I install the bulbs in place, I made sure that they work first by testing them using a 9-volt battery with a resistor in series, so I won't burn the bulb during the test. This is how the headlights and phototransistors look like after gluing to the vehicle using a super glue. Following the diagram on how to install the components, and after installing the components in place, you can see the bigger battery installed here. The bigger motor is here, the switch, the charging port, and the read contact over here. Let's turn the power on to see if it works, and it looks like it does. If I place a magnet close to the read switch here, you can see how the motor stops running, and that would be useful to stop the vehicle in some spot in the layout, like in the railroad crossing and such. Okay, let's give it a try on the layout. Okay guys, I appreciate you watching the video, and please give it a thumbs up and also do subscribe to the channel. Take care always, and until the next one, bye for now.